The empirical rule for normal distributions says that if you have a normal distribution, so that's just your regular standard bell curve, so just that guy, then most of your data has to be close to the mean. So in particular, 68% of the data has to be within one standard deviation of the mean. If you go 2 standard deviations, you get 95% of the data, and for 3 standard deviations you get pretty much everything. So 99.7% of the data is within 3 standard deviations of the mean. So let me redraw the picture to kind of give you an idea what's going on. Here's a bell curve. So it looks a little better than the other one. If I go, well, the mean's here in the middle. One standard deviation is about right here. So the empirical rule says this area right here in the middle, this is 68% of the data. If I go out another standard deviation, so go out about that same distance again, and add this area to it, now I've got 95% of the data. So that's within 2 standard deviations. And then if I go out another standard deviation, I'm almost off my picture, but just add in these little smidgets here. This is 99.7% of your data. Because of this 95% here, a general rule of thumb is that anything within 2 standard deviations is not considered to be unusual. Once you get more than 2 standard deviations away from a mean, though, then it's starting to feel that that's definitely an unusual situation. Alright, so let's do a few practical problems with this. First one, let's say a company's laptops have an average of $650 and standard deviation is $75. What percent of the company's laptops are from 500 to 800? Well, these questions are kind of rigged because the standard deviation is 75, so 2 standard deviations would be 150. And notice the dollar signs they gave us. 500 is 650 minus 150. 800 is 650 plus 150. So if I take the mean minus 2 standard deviations, well, that's the mean minus 150. That is 500. Same thing, the mean plus 2 standard deviations. That's the mean plus 150 is 800. So the range they're asking for in this problem is exactly 2 standard deviations of the mean. So 500 to 800, that is 2 standard deviations of the mean, or within 2 standard deviations of the mean. And our empirical rule says within 2 standard deviations of the mean, you get 95% of the laptops are priced between 500 and 800. Alright, that's pretty cool. Well, let's try something a little bit trickier. This one we're going to use a trick called a z-score. Let me tell you what that is right quick. The average lifespan of a hard drive is 30 months, standard deviation of 4 months. Would it be considered unusual for a hard drive to crash after only 24 months? So I don't know if this is true, but hard drives usually don't last more than 2 or 3 years, so I kind of made up some numbers. You should always back up your hard drives, by the way. So z-score, all the z-score is, it counts how many standard deviations you are from the mean. And the formula for it, well, to count how far you are from the mean, well, you actually see how far you are from the mean, and then scale that in terms of your standard deviation. All right. So for this problem, our mean is 30 months. So we have z is, well, it has a minus 30 in it. Our standard deviation is 4, so we're going to be dividing by 4. And our result, we got our hard drive crashed in 24 months. Seems like we got shorthanded a bit. But let's see if that was actually unusual or should we have expected it. Well, 24 minus 30 is negative 6. Negative 6 divided by 4 is negative 1.5. Well, our empirical rule said 2 standard deviations is pretty common. This is less than 2 standard deviations away. So if you get a z-score, anything between negative 2 and 2 is not unusual. So even though we feel like we got cheated a bit, we should have planned for this to happen. Not that uncommon. All right, let's do one more. So it says IQ scores have a mean of 100 and standard deviation of 10. What IQ score would put you in the top 16%? Well, for this one, we definitely need to draw a picture again. So let's draw us a bell curve. And we know the mean is 100. All right. The people we're interested in are the top 16%. So let's say this right here is 16%. Well, the way the empirical rule is worded, it gives symmetric things. So if I want to know about the top 16%, the empirical rule only tells me about the middle. So if I'm going to take out the top 16%, I also have to take out the bottom 16%. Okay? And now if I've taken out the top 16 and the bottom 16, what's left in the middle? Well, you know there's only 100% to go around, right? So 100, I subtract 16, that's 84, and then I subtract 16 again, that's 68. So this middle here is 68%. But hey, we should recognize that number. That's what the empirical rule says is one standard deviation. So this is 100, this is 100 plus one standard deviation, and this is 100 minus one standard deviation. And it told us that the standard deviation is 10, so anyone that's over 110 is in the top 16%. Likewise, if we went down a standard deviation, so 90, anyone that would be under 90 would be in the bottom 16%. All right, well, that's the empirical rule, and hopefully that made sense. And next one, we'll talk about Chebyshev's theorem, which the empirical rule is only for bell-shaped distribution. Chebyshev's theorem works for any distribution.